I want to talk about Fourier series. Fourier series is one of the most powerful discoveries ever made because it helps us represent waves in terms of sines and cosines. But before we do that, I want to talk about why these three integrals are equal to 0 because they're highly important to find the solutions to the Fourier series. Okay, let's get started. So as I mentioned, up above is a Fourier series, which is going to be the motivation for our video, but we want to talk about why this integral right here is equal to 0. This particular integral is pretty simple. We have an odd function in the sine, an even function in the cosine, and when you multiply that together, that becomes an odd. So the integral from negative pi to pi is just going to equal to 0. This is the next integral we want to talk about where m and n are not equal to each other. So let's go ahead and revisit the sum and difference rule for cosine. So here's the sum and difference rule for cosine mx plus nx and mx minus nx. And as you can see, everything looks the same except for the signs here at the end. But if we add these together, they go away. So now we add the left-hand side, we get 2 times these cosine values on the right-hand side. If you divide the 2 to the other side, you're going to get the function that we're looking for. So all we need to do is take the integral from negative pi to pi of this function right here. So here I have these integrals separated. I go ahead and just take the integral using u substitution, and whenever I plug in pi, I have multiples of pi within the sign, so that's 0. This entire thing cancels out, and so does the other one. This tells me that the integral that I was trying to find from negative pi to pi is just going to equal to 0. On to the last one. The last integral is going to work the same way, except this time we have signs where m and n are not equal to each other. We're going to use the same sum and difference rules for cosine, but in this particular case, we want the cosines to go away, so we're going to go ahead and subtract the top function minus the bottom function, which is going to give us this third line here where you have 2 times the expression that we wanted. We divide the 2 to the other side, and we have this right here that we have to integrate from negative pi to pi. You'll notice that it's basically the same thing as the second example, except we have a negative sign, so we know that this is just going to be 0. And that's all we need to know in order for us to start moving into the Fourier series.